Good morning, ladies and gentlemen. We are moving on to Lesson 15 today. Lesson 15 should start on page S96 or 97 since yesterday's homework left off at 95. Now, I'm going to give you all a few moments here to open up your books, get yourselves ready to go. Hopefully you've sharpened your pencils up to this point here since you've had about 5 to 10 minutes for this to get queued up. So if your pencil's already sharpened, hopefully you're already ready to class. Now remember what I said yesterday. Choosing not to do this is not acceptable. I promise you. I'll know who did it and who didn't do it. How I decide to do that is going to be entirely up to me, but it will be done the following Monday after I get back. So I'd be prepared. Don't let any opportunity escape you. I know we've had a wonderful week off from school, so we need to go ahead and reset and get ourselves back into the proper mentality. This is still a school. You had your vacation, you had your fun. You got to play your video games, you got to call your friends, you got to go sledding, you got to go slipping and falling, you got to bust your butt a couple times. You had your fun. We have a lot of work to do, and we've got a lot of stuff we got to catch up on. All right. With that being said, y'all should already be on the proper page, and this is the problem that you should be seeing. At least I hope you're seeing this one. So 2 identical cars need to fit into a small garage. The opening is 23 feet and 6 inches wide. And there must be at least 3 feet 6 inches of clearance between the cars and between the edges of the garage. How wide can the cars be? Okay. Well, let's do our cues real quick. Let's circle the numbers. So we got 23 feet and 6 inches wide. We've got 3 feet and 6 inches of clearance. And how many? Oh, yep, we got 2 cars. This is actually where it's important for us to circle the 2 because it is important to the problem. Now, what's the question? Okay, the question's pretty simple. How wide can the cars be? All right, well, that's not too difficult to figure out. I mean, we've been doing inequalities now for a few days, so this should be coming a little easier. Okay, so next is going to be boxing any keywords. Let's see, we've got, okay, so it is important that we have identical cars. All right, okay, the opening is 23 feet wide. Must be at least 3 feet and 6 inches of clearance between the cars and between the edges of the garage. All right, so what's next? Evaluate and draw. Okay, well, I've already drawn a picture for you. Okay, this is my version of the garage. Okay, you got car 1 here, and then you got car 2 here. Now, here's the garage. So I have an opening here. This is my opening. This is 23 feet and 6 inches. Now the distance from the wall to the car, from the car to the car, and then from the car to the wall is all the same. It's how many feet and inches? 3 feet and 6 inches. So 3 feet, 6 inches. 3 feet and 6 inches. You notice how I'm starting to do some shorthand here? 3 feet, 6 inches. All right, 1 apostrophe means feet, 2 apostrophes mean inches. So I got 3 feet, 6 inches. So all of that distance, the width of the car, plus the distance from the edge to the car and from the car to the car and from the car to the edge, all has to have a sum of 23 feet and 6 inches. Okay? Now, it's asking how wide can the cars be. So what's the maximum width the car can be without going too big? All right. Now, it's got us a requirement. We know the distance, but we don't know how wide the cars are. So we're looking for the maximum width of the car. So if we're looking for the maximum, are we looking at greater than or less than? Oh, see, I knew that was going to come out. I knew that was going to trick you a little bit. Sometimes when you hear the word maximum, you want to do greater than. Okay? That's not the situation here. We can't have a car bigger than the garage, right? We have to maintain ourselves within these parameters. So in that case here, the best situation is to use a less than symbol. Okay? We need to make sure that this is less than, kind of looked like a 2 there, didn't it? This needs to be less than 23 feet and 6 inches. Okay? Now, we're looking at the entire garage. Everything in the garage has to be less than 23 feet 6 inches. It can't be bigger. If it's bigger than 23 feet 6 inches, the cars don't fit. And that's not what we want. We want to make sure the cars fit. So we got 2 cars that are identical. See, it says identical. So we're going to represent the cars with a variable C. So I've got 2C plus, how many 3 feet 6 inches do you see? Right, 3. There are 3 feet 6 inches. So basically, oh, that's an interesting sitch there. Let's think about that. I know somebody was thinking it. I know somebody wanted to say it. 6 inches is exactly how much of a foot? Okay, we're not sure. All right, that's fine. How many inches in a foot? 12. So 6 inches is how much of a foot? Half a foot. So we can rewrite all this. This is 3.5 feet. So we're looking at 3.5 feet times 3. Because 3.5 feet shows up once, twice, 3 times. So 3.5 times 3. Okay. So now I've got 2C plus, let's go ahead and convert this real quick. 2 times 3 is 6. 6 plus 1 is 7. So we got 7 halves times 3 over 1. Okay, is less than, and we got that 23, we got that 6 inches again, so this is actually 23.5 feet. Okay, so we got 2C plus 21.5 is going to be less than, let's go ahead and convert this real quick. 2 times 23 is 46, plus 1 is 47, so 47.5. And I know what you're thinking, Mr. Hale, why are you converting those? Well, I'm converting them to make it easier on me. See, I'm working this problem as if it's me. What would I do? How would I solve it? What steps would I take? Just because I take these steps doesn't mean you're going to. You have the ability to choose your rate. Choose how you want to do it. But remember, you still have to come up with the same answer I do at the end. So if I know that the steps I'm taking are right, and I know I'm going to get the right answer, then if I was you, I'd be following along with me. But then double check yourself, though. I mean, if you're comfortable doing it your way, just make sure your answer matches mine at the end. Doesn't hurt my feelings if you don't do it my way. So we got 2C plus 21 halves is less than 47 halves. Now, I need to do some subtracting. Subtract 21.5 minus 21.5. All right, I'm left with 2C is going to be less than, these reduce out. Now what's 47 minus 21? 26. Oh, wait a minute, 26 halves. 26 halves. Well, isn't that just an interesting little feat? 26 halves. Well, I know 26 halves equals 13 feet, but let's not fool around with that right now. Or should we? I don't know. I kind of like the idea of changing the problem up a little bit. All right? Let's simplify this. 2C has to be less than 26 halves is the same as 13. Now it's easy. Divide by 2. So what's half of 13? Right. C has got to be less than 6.5 feet. So each car has to have a maximum width of 6.5 feet or less. Okay? There's your answer. You just found out the width of the car. Now, you could have done it your way, which I know some of y'all are sitting here saying, oh, Mr. Hale, I could have just sat there and taken 23.5 and then subtracted 3.5, subtracted 3.5, subtracted 3.5, and then just divided by 2. I have to go through all this, Mr. Hale. Why'd you go through all this work? Because what you're thinking is what I wrote. Ooh, interesting. Makes you wonder, doesn't it? All right, let's go on to the next one. All right, so a local car dealership is trying to sell all the cars that are on the lot. Currently, there are 525 cars in the lot, and the general manager estimates that they will consistently sell 50 cars per week. Estimate how many weeks it will take for the number of cars in the lot to be less than 75. Write an inequality that can be used to find the number of full weeks it will take for the number of cars to be less than 75. Since W is the number of full or complete weeks, W equals 1, which means at the end of week 1. Solve and graph the inequality. Ooh, now we got some graphing going on here. Let's get some graphing. We got a graphing game going. Oh, baby, love me some graphing. Let me get some graphing on. Well, I can't graph until I solve, right? So I guess I need to solve. All right, so let's get ourselves into our cubes. Circle all of our numbers. We got 525 cars on the lot. All right, 50 cars per week. Estimate how many weeks it'll take for the number of the cars to be less than 75. All right, that's next. Underline the question. Is there a question? No, there's a statement, though. Estimate how many weeks it will take for the number of cars in the lot to be less than 75. All right, box the key words. All right, so estimates that they will consistently sell 50 cars per week. All right, write an equality can be used the number of full weeks it takes for the cars to be less than. Ooh, look at there. I like that word. Less than, less than, less than, less than. And W is the number of full or complete weeks. W1 means the end of week 1. All right, now it says to evaluate and solve. All right, so evaluate and solve. Now, I know what you're thinking, Mr. Hale. Why haven't you already started writing? That's because I'm analyzing the problem. You know, it's not always just an instant answer. You got to think. You got to think about what you're looking at. Like, see, I know there's 50 cars per week. And the goal is to find out how many cars I can sell per week that'll give me less. That's it. See, once you start saying it out loud, it makes sense. So, there are 525 cars in the lot. Okay? Every week, I'm going to sell 50 cars. My goal is to make sure the total is less than 75 cars. And you're like, wait a minute, Mr. Hale. That's not how we've been doing it before. Where did this stuff come from? Okay, so let's explain it. What we're saying is that, and let's say it's Cameron. It's Cameron's car lot. You know, Cameron's got himself a nice car lot. He's got 525 cars in the lot. That's his starting inventory. He says every week I'm going to subtract 50 cars from my starting inventory. So at the end of week 1, I've gone from 525 to minus 50 cars. So now I'm sitting at 475 cars. Is 475 going to be less than 75? No, it's not. So week 1 is not the goal. I need to find out at what week is the car lot going to have less than 75 cars on it. So how did I come up with my inequality? Well, it's easy. Think about it. We're starting with 525 cars. At the end of week 1, what have we done to the lot? We've subtracted 50 cars. So we've started with our total. And we've subtracted 50. That's why this problem looks different. The variable is second this time. It's not first. So we need to be very, very careful. Okay? Now, I like this problem because this is going to bring in something we learned last week when we were talking about the whole positive and negative number scenario. All right? So be careful and watch. So, remember what I told you. We always take care of everything that is not attached to the variable. So we have to get rid of the 525 first. Is the 525 positive or negative? It's positive. So that means we're going to subtract 525 minus 525. Okay, 525 minus 525 is going to be 0. Okay, let's change colors real quick, shall we? Let's go with green. All right, so now we're left with a negative 50W is less than. Okay, so now I've got 75 minus 525. Am I going to have a positive number or am I going to have a negative number? I'm going to have a negative number. So I'm going to have a negative 450. Okay? Now, I need to get the W by itself. So what am I going to divide by? I'm going to divide by a negative. Negative 50, divide by a negative 50. A negative 50 divided by a negative 50 is W. A negative 450 divided by a negative 50. Well, the zeros cancel out. So what's 45 divided by 5? That's right, it's 9. Is it going to be positive or negative? It's going to be positive. But what about the inequality sign? Think about it. Go back to our lessons. Is it going to be preserved or reversed? Okay, remember, think about it this way. So I've got 4 is less than 5. If I multiply both sides by a negative 1, I get a negative 4 and a negative 5. Is a negative 4 still less than a negative 5? It's not. A negative 4 is now greater than a negative 5. So the inequality sign was reversed because we multiplied both sides by a negative number. So this is actually going to be greater than. So W has got to be greater than 9. In order for there to be less than 75 cars on the lot, he's going to have to sell he's going to have to be selling for 9 to 10 weeks. Or actually, it's got to be greater than 9, so it's going to be 10 weeks. That's how many weeks it's going to take for the number of cars to be less than 75. It's got to be 10 weeks. So there you go. There's your answer. Don't let this cause a mistake. Just think about it. Always remember what we did in that nice little one where we had to figure out reverse versus preserved. Remember that. Okay? Now it says graph the inequality. Okay? So it says W is greater than 9. All right. So here's my number line. This is how you graph. My bad. Do not know what happened there. That's kind of crazy looking. All right, so we got a 9. So we're going to go with 0 being all the way over here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, we're going to spend some time on this, and I will explain it more in detail when I get back or hopefully in the next lesson. All right? Actually, you know what? We can do it right now. Okay. Equality signs. We got greater than, less than, greater than and equal to, and less than or equal to. When you have one of these two inequality signs, when you graph, you use an open circle. When you see one of these two inequality signs, when you graph, it's a shaded in circle. The idea is an open circle says it's every value but that one, okay? Whereas a shaded in circle says it's every value including that one. So I've got W is greater than 9. Here's my greater than sign, so it's got to be an open circle. So open circle, and then I'm going to shade everything that is greater than 9. Shading everything that is greater than 9. There you go. You just graphed your inequality. That's it. That is all there is to it. That is graphing your inequality. Now, I make sure that I write this in my notes. Do not forget that. Do not let that slip through your fingers. It will come back to get you. All right? So, the cost of renting a car is $25 per day plus a one-time fee of $75.50 for insurance. How many days can the car be rented? The total cost is no more than $525. All right, so let's do our cubes. All right, we've got 25, 75, 50, 525. All right, next we've got a U. Underline the question. How many days can the car be rented if the total is to be no more than $525? Box the key words. $25 per day, one-time fee, how many days, no more than. All right, so now it's time to evaluate. Write an inequality to model the situation. Okay? So I've got a one-time fee of $75.50. That's my insurance. It costs me $25 per day to rent the car. So I don't know how many days I'm going to have the car. So I know that how many ever days it is, it's going to be multiplied by 25, plus my one-time fee is $75.50. No more than. What inequality sign is going to be no more than? Correct. It's got to be less than or equal to. Okay? Or actually, well, no more than. Let's go with just less than. Less than $525. So all this cannot equal more than $525. It's got to be less than that. So there's our inequality. Step 2 says to solve and graph it. So let's get to solving, my friends. Yeah, actually, I think that's where we're going to stop. I'm going to chill out right here for a minute. So I'm going to sit there and we're going to monitor. We're going to walk around looking and making sure y'all got your stuff getting done. Ooh, I don't see you doing your work. Ooh, I see you doing yours. I see you doing yours. Oh, look at all these candies I'm going to have to give when I get back. Think about all these hundreds these kids are going to get. Woo-wee. And y'all sitting here thinking, Mr. Hale crazy. Mr. Hale ain't even here, and he's sitting here saying, I'm doing my work. Yeah, right. I know what y'all thinking. I was once in your shoes. Only difference is I didn't have this technology when I was in middle school. Whew. All right, so solve and graph the inequality. Let's get to solving. All right, so let's rewrite the inequality. 25D plus 7550 is less than 525. All right. Okay, so we're going to subtract 7550. Left with 25D. It's going to be less than, and as much as I'm great in my head at math, I'm still going to use a calculator. 449.50. All right, then we got to divide by 25. So D is going to be less than, all right, 449.50 divided by 25. Ooh, we got some problems. 17.98. So if it's got to be less than 17.98, can I rent the car for 98 hundredths of a day? Nah, I can't. So D, it's got to be less than 18 days. So we'll graph our inequality real quick. Going to come down here, give myself plenty of room. All right, so D is less than 18, so we're going to go with 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. All right, so D is less than 18. It's going to be an open or closed circle. Right, open circle, because it's not going to include 18 weeks. It's going to include, or not, 18 days. But it could be everything less than 18, okay? Everything less than 18 is a solution. So he could have rented it for 2 days, 5 days, 10 days, 12 days, 13 days, 17 days. But he could not rent it for 18 days if he wanted to keep his cost below $525. All right? Now, hopefully, y'all pause this and y'all already got all your work done. All right, so for each problem, write, solve, and graph the inequality. Interpret the solution within the context of the problem. So Mrs. Smith decides to buy 3 sweaters and a pair of jeans. She has $120 in her wallet. If the price of the jeans is $35, what is the highest possible price of a sweater if each sweater is the same price? Now, I'm not going to give you the answer. What I'm going to do is I'm going to give you your inequality. If your inequality matches mine, then you're good. You can work the problem and solve it for your answer. Okay? So my inequality is actually pretty simple. Okay? We're going to go through this. I'm going to still use my cues real quick. I got $120, $35. What is the highest possible price of a sweater if each sweater is the same price? Let's see. Next is going to be boxing keywords. 3 sweaters. Highest possible price. Each sweater is the same price. All right, so time for inequality. All right, so I've got 3 sweaters plus the cost of the jeans, and then it's going to have to somehow be $120. Can I go over $120? You're right, I can't. So it can't be greater than. It's got to be less than or equal to. All right, so that's your inequality. That's all you did. If you've got that inequality, you can solve for that problem. All right? I mean, based on my estimate, it'd be about $22.50, give or take. No, maybe $27.50. All right, that's just me looking at the problem. All right? You can take your steps from here. Solve the answer. Find out what the cost is per sweater. Talk to your group. See if you and your group come up with the same answer. Do not let your group have a wrong answer. Talk about it. Oh, and by the way, just to remind y'all, the substitute does have a seating chart, so you better be sitting in your right groups. All right, moving on. The members of the select chorus agree to buy at least 250 tickets for an outside concert. They buy 20 fewer lawn tickets than balcony tickets. What is the least number of balcony tickets bought? Okay. Interesting. All right, so we've got balcony tickets, and then we got lawn tickets. The lawn tickets, we don't know what the balcony tickets are, but we know the lawn tickets are going to be 20 fewer than the balcony tickets. So whatever they bought for the balcony tickets is going to be 20 less than that. Okay? They bought a total of 250 tickets. Now, I know you're asking, Mr. Hale, why'd you do that? You'll see in just a second. All right, so they bought at least 250 tickets. They bought 20 fewer lawn tickets. What's the least number of balcony tickets bought? All right, so let's see. 20 fewer lawn tickets. All right, so what's the least number of balcony tickets bought? So the least number. All right. Least. That's kind of pretty self-explanatory. It's got to be less than 250. So why'd you do this, Mr. Hale? Why did you do this right here? Well, that's actually pretty self-explanatory. I can't have 2 variables. But I know that the lawn tickets is going to be equal to whatever the balcony tickets are minus 20. So I'm going to have a balcony tickets plus the balcony minus 20 for the lawn tickets. So I've got 2B minus 20 has to be less than 250. And then you would solve it. Once you find out that, then you find your answer. You remember, it's saying the least number of balcony tickets. So we really don't care about the lawn tickets. We just need to know how many balcony tickets. That's why I used this expression instead of using an L. Okay? It's called a substitution. All right? You already know what the values are. You already know what because they told you. They told you that there are 20 fewer lawn tickets than balcony tickets. So it really doesn't make sense to have 2 variables. All right. Once you solve that, you're done. You're done with your work. Now you got to do your classwork and homework. So again, if you've gotten through this in a timely manner, which I think you should have, these are your problems. S101, all the problems. You can either start on it in class. If you don't finish in class, this is one that I do expect you to take home and finish for homework. Remember, these videos are online. If you did not get it in class, go home, spend 30 minutes, watch it on your TV, watch it on your cell phone, okay? Remind your parents that this is math. This is important to you. I promise you 30 minutes just to sit there and try to understand this, I promise you, your parents will understand. Don't let this slip through your fingers. Don't let this opportunity to fall right through your hands. Success always starts with you. All right. Y'all have yourselves a good day. When the bell, oh, no, I'm sorry, we no longer have bells. When the substitute teacher dismisses you, all right, you are to line up in the hallway. Be ready for Mr. Joyner. If Mr. Joyner's back, oh, yeah, he should be back. And line up for Miss Walker and all them, okay? Thank you so much. You guys have yourselves a wonderful day. And remember, like I said, make sure you keep up with this. All right? Remember, we'll be back on Monday. And we got a lot of grades to put in the grade book.